Bago natin topic ngayon is about sa flip-flops and related devices. Okay? So, tingnan natin. So, having discussed a combinational logic circuit at length on previous chapter, right? So, combinational logic circuit tayo sa previous chapter. So, focus tayo in this module sa sequential logic circuit. So, iba to sa combinational, ngayon is sequential na. So, while logic gate is the most basic building block sa combinational logic, dito naman yung counterpart niya is flip-flop. So, sequential logic is flip-flop na. Hindi na dito logic gates. Okay? So, sa module na to is bigyan ko ng brief introduction to different types of multivibrator. So, bistable, ito yung complete technical name for flip-flop. Okay, bistable. So, monostable, saka unstable. So, yung flip-flop is not only used individual for variety of application. It also form the basis of many more complex logic function. So, yung counter, saka yung register, yung sample natin sa uh, flip-flops. So, yung large variety of flip-flops having varying a functional table, input clock requirements, and other feature. Okay? Sa module na to, mapag-aralan natin yung function nila, truth tables, etc. Okay? So, simulan natin sa multivibrator. So, sa multivibrator, is like a familiar sinusoidal oscillator. Our circuit with regenerative feedback. Okay? So, regenerative feedback plan. With a difference that they produce pulse output. Yun yung difference niya sa regenerative feedback. Ay, sa sinusoidal oscillator. Okay? So, there are three basic types, multivibrator, namely bistable, mono, and astable. So, sa bistable, a stable multivibrator circuit is one in which both low and high output state are stable. So, low and high stable tayo doon. So, state na yan. So, irrespective of the logic status of the output, low or high, it stays in the state unless a change is induced by applying an appropriate trigger pulse. So, kaya siya tinawag na stable kasi hindi mag-change yung kanyang status sa low or high kung hindi tayo mag-i-induce ng appropriate trigger pulse. Okay? So, kailangan mo muna ng pulse para ilipat niya yung low sa high or vice versa. So, dito, the operation of bistable multivibrator is identical to that of a flip-flop. So, kaya sinabing technical term ng flip-flop yung bistable. Kasi yun yung trabaho talaga ng flip-flop, yung bistable multivibrator. So, napakita natin dito yung basic bistable multivibrator circuit. Okay? Ito ay naka-fixed bias type. Dahil meron ibang klase na naka-self-bias at saka naka-emitter coupled type. Okay? Kung naalala niyo yung mga fixed bias, mga ganyan self-bias, o emitter coupled sa inyong past subject. So, the operational principle of all type is the same. Okay? So, ito yung ating multi-vibrator na circuit. So, ito, kung yung logic circuit is merong inside niya is may circuit diagram. So, ito rin is yung inside ng ating flip-flop is may circuit diagram. So, ito yung ating VO1 or VC1 and VO2 and VC2 sa supply voltage natin positive saka negative. Okay? So, meron tayong transistor na sabi nga dito is naka-fixed bias. Okay? Fixed bias yung kanyang setup. So ngayon, try ko explain kung ano ang ibig sabihin niyang circuit na yan, kaya siya naging bistable, okay? So ayan yung habang pangyayari diyan. So sa figure na 'to, yung both transistor Q1 and Q2 cannot be simultaneously on or off. So alternate yan. Q1 is on, so yung Q2 is off. When Q1 is off, siyempre si Q2 on. So in order to vindicate this statement, let us assume that both Q1 and Q2 are conducting simultaneously. So, owing a slight circuit imbalance which is always there, the collector current in one transistor will always be greater than the other. Let us assume na yung C2, IC2 is greater than IC1. So, yung IC1 is lesser means yung VC1 is higher. Okay? So, asan yan? Ito yan VC2, ito yung IC1. IC2, IC1. Okay? So, kung si IC2 is greater than dito sa IC1. Okay? So, si BC1, ito, is higher. Okay? Since, kasi, siya is naka-copy Q2 base. Ito, Q2 base. Ito yung base niya. Okay? Arise in VC1, arise daw dito, leads to an increase in Q2 voltage. O, tama naman. Kasi doon na-connect yung base niya. Increase in Q2 base voltage result in increase in IC2. C2. And an associated reduction in BC2. Ito yung BC2. BC2. Ay, BC1. Sorry. Tama? Dito pa lang. Dito ako. Associated reduction in BC2. Reduction in BC2 leads to a reduction in Q1 base. O, tama rin. Kasi dito yung base ng voltage. And associated fall in IC1. So, bababa yung current dito sa taas. With result that the BC1 increase further. So, tataas to. So, the slightly circuit imbalance has initiated a regenerative action that culminates in transistor Q1 going to cut off and transistor Q2 getting driven to saturation. So, pag nag-cut off si Q1, saturated naman si Q2. Okay, to sum up, whenever there is a tendency of one of the transistor to conduct more than the other, it will end up with that transistor going to saturation and driving the other transistor to cut off. Yung sinasabi ko. So, kapag saturated yung isa, cut off isa. If we take the output from the Q1 collector, so ito yan, Q1 collector, BC1, it will be low. Okay? So, kasi si BC1 is saturated low. Okay? Initially in saturation. If we apply a negative going trigger to the Q1 base to cause a decrease in its collector current, a regenerative action will set it that would drive Q2 to saturation and Q1 to cut off naman. So ngayon, trigger tayo ngayon ng negative sa Q1 base para si Q2 is mag-saturate and then si Q1 naman mag-cut off. So as a result, the output goes high na. Okay, so yung sinasabi na kapag nag-trigger, lilipat na ngayon yung kanyang state. So the output will stay high until we apply another appropriate trigger to initiate a transition. Both of the output state when the output is low and also when the output is high are stable and undergo a change only when a transition is induced by means of appropriate trigger pulse. That is why it's called a bistable multi-vibrator. Okay? So, kapag nag-on yung isa, cut off yung isa, high siya. So, pag nag-trigger, naman, magpapalit ng status yung Q1 sa Q2, kakaroon naman siya ng low yung output. Hanggat walang nag-trigger, hindi siya magpapalit. So, Kaya siya bistable. Kahit sa low, kahit sa high, stable. Okay, so next, Schmidt trigger. So Schmidt trigger is slightly variation ng bistable. So basic Schmidt trigger circuit is ito. Okay? If we compare bistable circuit sa Schmidt trigger circuit, that we find that the coupling from Q to collector, ito, to Q1 base. Okay? In case a bistable circuit is absent. In the case of Schmidt trigger circuit, instead the resistance Re provides the coupling. The circuit function as follow. When Vin, si Vin, ay tingnan muna natin. Kumpara muna natin. So ito, ano yan, photographic memory nyo. Pansin nyo rito, ang pinagkaiba niya is wala siyang dito. Walang RC circuits in base ng Q1. Walang RC circuit dito. So, dun agad yung ating Vin na dapat ito. Dito siya. Okay? Tapos, si R2 is siya yung RE. Ito yung RE. Okay? Siya na ngayon yung naging RE. Kasi ito, dapat ground na siya, pero kumonect sa resistor. Ayan. Sa halip na mag-ground, kumonect muna sa RE bago dumating sa ground. Yan ang pinagkaiba ng Schmidt trigger. Okay? So, kapag si Vin is 0, transistor Q1 is cut off. Siyempre, wala tayong voltage sa base. And then, si Q1, so coupling from Q1 collector to Q2 base, Q1 collector to Q2 base, ito, drives transistor Q2 to saturation. Kasi cut off to, di ba? Cut off to, so open circuit siya. So, si BCC pupunta sa base ni Q2. Kaya magsasaturate siya. With the result that VO is low. Ito, maglo-low to. Kasi saturated to. So, parang short circuit yan pababa. Mababa tong si VO. If we assume that VCE2, ito yun yung VO, VCE2 yan, is 0, then the voltage across RE, ito, is given the equation, ito. So, VCC times RE over RE plus RC2. So, RC2 ay nandun sa may voltage out. Okay? Or VCE2. VCE2 sa voltage out. Isa lang. And also emitter voltage from transistor Q1. No? Emitter voltage. To make transistor Q1 conduct, syempre yung Bin must be at least 0.7 para at least 0.7 more than the voltage across RE. Okay? So, kaya yung formula na to is nilagyan pa ng 0.7. Kasi at least 0.7 dapat dito. Alam naman natin yan. Puntang emitter. 7. So, kapag si Vin exceeds sa voltage, Q1 start conducting. Okay, so active na siya. So, the regenerative action again drives Q2 to cut off. So, kapag nag-act na to, kung nag-act na yan, si VCC is hindi na to pupunta rito sa base. Dito na siya dadaan kay Q1. So, kaya si Q2 is mag-cut off. Wala na tayong base voltage. So, kaya yung output natin goes high state. High na siya. Eh, dahil dito yun. Dito tayo. High na siya. Dito tayo kumukuha ng low. Dito kumukuha ng high. So, ngayon ang formula niya, pag high na siya, is mapapansin nyo, ang pinagkaiba na sa formula is yung RC1. Kasi kanina, nung low state sa RC2, ngayon is dito na tayo sa RC1, nung high state, kasi yun ay may kinalaman sa Q1. Kasi cut off na itong si Q2. Okay, the resistor Q1 will continue to conduct as long as Vin is equal to or greater than the value given by the equation. So si V in falls below this value, Q1 tends to come out of saturation and conduct less heavily. So the regenerative action does the rest, with the process accumulating in Q1 goes to cutoff and Q2 saturation, plus the state of output high or low depends upon the input voltage. Okay? So ito yan. So the high and low state of the output corresponds to the two distinct input level given by the equation na 0.2 and 0.4. Okay, 0.2 and 0.4. Kasi ito yung para sa low, ito yung para sa high. Okay. The value ng RC1, RC2, RE, and BCC, the Schmitt trigger circuit, therefore exhibit hysteresis. Exhibit niya is hysteresis. Shows the transfer characteristic of Schmitt trigger circuit. So the lower trip point VLT, ito, and the upper trip point VUT. Ayan. Ito yung kanyang formula para dyan. Kanya nakuha dito nga sa 10.2 saka 10.4. Yan din yan. Mapapansin nyo, ayan, RC1 sa RC2, same formula, yun yun. Yung VLT saka VUT. Kasi ito is para sa high, low, para sa high. So, ito lang yung graph ng ng flow. Okay, flow lang yan. Flow ng voltage. Okay, characteristic yan ng Schmitt trigger. So, ulitin ko, si bistable is high siya permanently hanggat walang another signal na pinadadala na galing dito sa VO2 sa Q1 and then ganun din sa vice versa, hindi siya magbabago. Wala namang pinadala dito signal sa Q2 naman. And then dito naman sa Schmitt trigger is ganun din siya bistable. Yun nga lang is nakadepende lang tayo sa voltage ni base voltage ni Q1 kung mag-high siya or mag-low. Pag kasi ito is hindi mo na cut off, di high siya, low siya. Pag naman siya is nag-saturate, di high siya. So, depende sa Vin. Okay, yan ang pinagkaiba ni Schmitt trigger sa bistable. Then, yung ating ikatlo is monostable. Ano naman si monostable? Also known as monoshoot. Pag narinig mo na yung monoshoot. So, which one the state is stable and the other is quasi-stable. So, dalawa yung kanyang state. Isang stable sa isang quasi-stable. So, the circuit is initially stable state. It goes to quasi-stable state when appropriately triggered. It stays in the quasi-stable state for a certain time period. So, after which it comes back to the stable state. So, kung si bistable is kapag nag-trigger, saka lilipat sa low, trigger na high, trigger low. Ito naman, isang trigger lang, lilipat siya sa quasi-stable, then a certain time period, babalik ulit siya sa stable. Kahit wala na tayong tinitrigger na signal. Kaya siya tinawag na monostable. Multi-vibrator. Okay? So, pakita ko yung kanyang circuit. Yan. Papansin nyo dyan, kung kayo ay observant, wala na tayong RC circuit dito sa base ng Q2. Kasi sa bistable, is meron tayong RC circuit dito. Puntang Q2. Dito, ang nangyari, nagkaroon lang tayo ng resistor na parallel sa each other. Okay? So, yan. Nawala yung parallel na resistor sa C. So, circuit function as follows. Initially, transistor Q2 is saturation as it gets its base bias from VCC through R coupling from Q2 collector to Q1 base. Ensure that Q1 is in cutoff. Okay? So initially, yung Q2 saturated. Okay? Initially. Saturated na agad yan. And then, as it gets the base bias from VCC, yung base bias natin is sa VCC. Okay, VCC, yung nagsusupply sa base nitong Q2. And through our coupling from Q2 collector to Q1 base, that Q1 is cut off naman daw. So, yung Q2 collector, ito yan, Q2 collector, papuntang Q1 base, ensure that the Q1 is cut off. So, ito, si collector nito, nag-i-ensure na cut off si Q1. So, now it's appropriate trigger pulse induce a transition in Q2 from saturation to cut off. The output goes to high state. Yan. So, nag-trigger tayo. Ngayon, si Q2 nag-cut off. So, ngayon, si output natin napunta sa high state na. This high output when coupled to the Q1 base turns Q1 on. On na to ha. Adinin nyo. On na siya. Since there is no direct coupling from Q1 collector to Q2 base, so Q1 collector to Q2 base, wala tayong coupling, walang RC circuit. Ayan. So, the high output when coupled to Q1 base turns Q1 on. Since there is no direct coupling from Q1 base, it's necessary to energetic process to set in. Q1 is not necessarily in saturation. Okay? So, not necessarily saturated siya. So, however, it conducts some current. So, si Q1 collector, voltage falls by ito, yung current saka RC1. And the Q2 base voltage falls by the same amount. Siyempre, kasi nakabuktong si base doon. Sa collector ni Q1, nasa base ni Q2. So, same amount. So, as the voltage across the capacitor, cannot change instantaneously. Right? To sum up, the moment we applied the trigger to Q2 to cut off, and Q1 started conducting. But now there is a path for capacitor to charge through sa VCC na dumaan sa R. Okay? And conducting transistor to charge through R and conducting transistor. So, the polarity of voltage across C, such that Q1 base potential rise the moment the Q2 base voltage exceeds the cut-in voltage, it turns Q2 on. So, yun yan. So, in short, ito is natural na on. Sa una, bigay tayo ng signal. Nag-on ngayon si Q1. So, ngayon, yun ay quasi-stable. Yung state na yan. Kasi nag-on si Q1. Yun ngayon, habang nag-charge si capacitor ng ilang seconds, saka hanggang sa hindi niya, hanggang makuha na niya yung voltage para ma-cut in dito sa Q2, yung 0.7 volts, is ang mag-o-on si Q2. So, yun yung time na nasa quasi siya hanggang on si Q1, hanggang nag-charge. Yun yung time, yung sa charging. Puno na to at nabuksan na ulit si Q2, nabalik na ulit siya sa stable state niya. Okay? So, yun yung sinasabi dito. So, the owing coupling through to R1 turns Q1 off. So, nag-off na siya. And we are back to original state, the stable state. Whenever we trigger the circuit into the other state, it does not stay there permanently and returns back after a period of time that depends upon RC. So, ito yan, RC. So, the greater the time constant ng RC, the longer is the time for which it stay in the other state, called the quasi-stable state. So, nakadepende sa design nyo naman dito. Okay, ulitin natin. Sa bistable, nag-trigger, lilipat tayo ng state. Sa Schmidt naman, kapag nakadepende tayo sa volt na nasa base ng Q1 para mag-iba ng state. And dito naman, kapag nag-trigger tayo, pupunta tayo sa quasi-state, pero sandaling oras lang, babalik tayo sa stable state. Okay, yun naman si mono. So, sandali lang siyang mag-iba, pero babalik siya. So, ngayon naman, ating last sa ating multivibrator is a stable state. So, neither of the two state is stable. So, both output states are quasi-stable. So, kaya siya walang stable kasi parehas na yung Q1 natin sa Q2 is quasi-stable. So, siya is, hindi nyo siya kailangan i-trigger na para mag-iba ng state. Siya is always paiba ng paiba state. So, the output switch from one state to other and the circuit functions like a free-running square wave oscillator. So, pag nakakita kayo ng square wave is high state, tumaas, and then yung charging natin ng capacitor yung flat. Then, kapag nag-charge yung capacitor, mag-shift na ngayon siya ng state. So, nag-low, charging ulit ng capacitor. So, flat ulit. Then, change na siya ng state. So, nag-up na siya. Kaya siya square wave. Okay. So, it can be proved that this is a type of circuit, neither the output state is stable. Both state low as well as high are quasi-stable. So, the time period for which the output remains low and high depends upon the RC. So, kung RC1, so RC2, depende sa kanila kung gaano katagal yung paglipat. So, the output is a symmetrical square waveform. Circuit function as follows. Let us assume the transistor T1 is initially conducting, that is the output slope. So the capacitor C2 in this case charged through R2 and conducting transistor from VCC, and the moment ng Q1 base potential exceed its cut in voltage, it is turned and fall in Q1 ulit. So ito yun. Yan yung ating circuit diagram. So, pwede, kapag nag-on yung isa, pag on tong Q2 is low state. Okay, low yan. And then, magcha-charge si C2. Then, nakapag-charge na. Then, mag-on si Q1, nag-high state na. Nag-charge si C1 naman na ngayon. Kapag okay na ulit yung voltage niya, mag-on na ulit si Q2. Yan. Kaya sila ay alternate lang. So, the Q2 base as voltage across capacitor cannot change instantaneously. The output goes to the high state as Q2 is driven to cut off. However, C1 has now started charging through CR1 and the conducting resistor Q1 from VCC. The moment naman na Q2 base potential exceed the cut-in voltage, it is again turned on. So with the result that the output goes to the low state. So this process continue and owing to the both decoupling and being capacitive, neither of the state is stable. The circuit produces a square wave output. So yan ay continue na. Process continues. Continues na continue. Okay? So yan. Nag-gets nyo ba yung pagkakaiba-iba ng apat? Hello? Nag-gets nyo ba yung pagkaiba-iba ng apat? Hello? Nag-gets nyo ba yung pagkaiba-iba ng apat? O yung iba, pero kay Engineer Ampuan,
Nagets naman po, sir.
okay, kaya nyo i-identify yung apat ha. So, yan yung ating ah 4 types ng multi-vibrator. So, yan yung about sa flip-flops. Kalimutan nyo muna yung logic gates. So, ito yung bago na. So, yun ay iba na to. Sequential na tayo. Tapos tayo sa combination na. Okay? Pero, yan ang mga parts ng microprocessor. Okay? So, any question? Question, guys. Question?
Wala naman po, sir.
Okay, sige. Okay. Wala. So, ngayon is about naman tayo sa ating lab. Okay? Lab. So, sa ating lab is tapos na tayo sa yan. Tapos na tayo sa ating turbo. So, ito is about sa microprocessor na nasa computer. So, ngayon naman is about naman tayo sa microcontroller. So, meron din siyang microprocessor pero ito is microcontroller. So, a tiny simple computer. So, very useful siya para sa physical computing, the process by which computer are able to interact with their surroundings by a sensor and actuator. Sensor natin, yun yung ating input. So, actuators, yun yung ating mga output. So, pwedeng speaker, pwedeng motor, pwedeng LED, so, pwedeng 7 segment, ano yung actuators na gusto nyo gamitin. So, it is so versatile that is very frequently used in do-it-yourself project. Ito yung kanyang parts. Meron tayo dito input ng jack or USB port para sa programming niya. Meron tayong port na 9 volts, power adapter. So, kapag siya is nakasaksak sa USB port, meron siyang supply galing sa computer. So, okay yon para i-program siya. Then, kapag ginamit nyo na siya ng standalone, need nyo na siyang supplyan ng 9 volts para ma-process yung inyong program na ma-store sa loob ng Arduino. So, ito yung ating mga power pins, analog pins, and digital input-output. Okay? Then, yung reset button para i-reset yung ating program na nasa Arduino. So, once a program is uploaded to the board, it will run forever. Even the power is cut to the Arduino, the program is still stored in the memory of the Arduino and execute once power is returned. The Arduino is usually powered by computer using USB cable, pero pwede rin mo siyang 9 volts battery or power adapter. The Arduino can be used like a battery to power simple device like LED, right? As well as receive signal from device like photosensor, photoresistor. Okay. This is done by connecting them in I/O pins. So, digital pins can be used as input para sa sensor at output naman para sa actuators. Kaya lang, they're limited to they only have 2 settings, high na 5 volts and low na 0 volts. May analog pin naman is pwede siyang input only para sa sensor. Kadalasan kasi, sensor natin are analog. So, they can measure a range of values between 0 volts to 5 volts. All 3 ground pins are identical. May makikita kayo dyan ground pins sa mga dito. Ayan, GND. So, lahat dyan is same lang. Never allow a direct connection or short circuit between any power pin and ground. This is permanently damage the Arduino board and could potentially harm it. Okay? Yung ating overview sa ating Arduino. So, ito naman yung guide natin Nakakuha kayo sa www.arduino.cc ng Arduino IDE para sa kanyang software. Okay? So, ito yung ating itsura ng ating software sa ating Arduino. Okay? So, yan. Kita nyo sa inyong screen. So, pagsaksak nyo ng Arduino, punta lang kayo sa tools. Tingnan nyo kung anong Arduino yung gamit nyo. Okay? And then, lalabas dito sa port. Kakaroon ng highlight yan kung anong port yung nakasaksak na Arduino sa inyo. So, ma-detect nyo. Okay? And then, dito yung ating sketch na tinatawag. Yung sulatan ng program. Then, pwede nyo i-verify kung may error ang inyong program bago nyo siya i-upload. So, yung ibang button is new, open, and save. So, pwede kayo mag-open ng sketch, save ng sketch. So, yan ang itsura ng software ng ating Arduino. Ngayon, kaya ako nasabi yan is mag-upload ako ng lab natin na may kinalaman naman sa Arduino. So, kung sino yung may Arduino sa inyo, is good. Kung sino na may wala, pwede naman kayong makigamit sa ibang meron. Our choice is meron din ditong Arduino sa ating department. Item. Or pwede rin naman na yung meron sa inyo is gagawin nyo sa bahay yung ating lab. Then, kita nyo na lang through online kung paano nagawa at masagutan nyo ang ating activity sheet. So, yeah. Any questions sa ating lab? Any question?
Wala po, sir.
So, sino ang may Arduino sa inyo? Sa inyong bahay? Anyone? Anyone? So, walang may Arduino sa inyo na personally. So, kung wala, and then, kung walang Arduino sa inyo personally, is yun, pwede yung isa sa inyo is makigamit ng Arduino na nandito sa ating department, nasa office, para gawin yung ating lab. And then, through online, is pwede naman ma-share sa inyong classmate yung inyong gawa na video kung paano siya napanood, ganun, something. Kung ano man. So, yun. Okay. O meron kayong kakilala may Arduino, okay lang din. Hindi naman kailangan bumili. No need. Inuulit ko, no need bumili. Okay, kung wala ng question sa ating lab is attendance, guys.